Hello guys, once again, Sinbad here from the BEG, and today I am here to give you another maths tutorial. Now this is the second part of one I recorded only 1 hour ago, because I had spare time tonight and I thought what better to do than recording to help you guys pass your GCSE maths. Okay, so last time in the last trigonometry video we learned about how right angle triangles work, okay? And what we learned is Pythagoras' theorem, and that is that a squared, or h squared, I think I used, h squared equals a squared plus b squared, where h is the longest side, okay? And now we're going to develop that a bit further, okay, using something called trigonometry. So, for the purposes of trigonometry, I've relabeled these sides as h, still, for the longest side, which is the hypotenuse, and then o for this side and a for this side. Now, the reason I've called this O is because it stands for opposite, and it's opposite this angle here, x, which is the angle we're trying to find. Sorry, it doesn't look very much like an x, but x is the angle we're trying to find. And A stands for adjacent, okay? And that is along the x, the angle that you're trying to find. So for any angle, there's going to be the hypotenuse and the adjacent, and then the opposite it. Okay, that's why it gets its name. So, if we're going to write Pythagoras using these letters, you use the longest side, h squared equals o squared plus a squared. Okay, nice and simple. So, if we go over that, say we had a equals 3, o equals 4, therefore h equals the square root of 3 squared plus 4 squared equals square root of 9 plus 16 equals square root 25 equals 5. Okay? And so in this case h would equal 5. But we can go a bit further than that, because we will write than that, and we understand that we can use angles to find out lengths. Okay? And we use this using a formula known as SOHCAHTOA. Okay? So I'm going to write that out at the top here. SOHCAHTOA. Okay? And everyone has different ways of remembering this. Personally, I use a different method to this. But this is the traditional one, and it's the one that will be taught to you in school, which is how you memorise this. And this uses 3 calculator functions called sine, cosine, and tangent, shortened on your calculator to sine, S-I-N, cos, C-O-S, and tan, T-A-N. Okay? So, what's the meaning of this? Because it still doesn't make sense, it's just a list of letters. Well, if we say that x is the angle here, this is the opposite, O, this is the adjacent, A, this is the hypotenuse, H, we can use these functions to work out the values of an angle or a side. So, let's start with the SO in SOHCAHTOA, S-O-H. So, the sine of x equals opposite over hypotenuse. Okay? That means that if we go back to our original example, O equals 4 and h equals 5, then the sine of x will equal 4 over 5, or 0.8. Okay? Now what we can do to work this out is x equals sine to the minus 1 of x of sine to the minus 1 of 0.8. So essentially what we've done here is we've done the inverse sine of both sides. So that basically means you do the opposite. So for example, if you had, I'll do a very simple example here, x plus 1 equals a, the inverse of plus 1 is simply minus 1, and so you get x equals a minus 1. Equally well, if you had 2 times x equals a, the inverse is divide by 2. So you divide both sides by 2, is x equals a over 2. And a final example, if we had x squared equals a, then the inverse is the square root, and so x equals square root of a. And that's exactly what we're doing here with the inverse sign to get your answer. Okay? Sine x, you can write it with or without the brackets, equals a. So if we do the inverse sine, then we get x equals inverse sine of a, and you can calculate that on your calculators here with 0.8. Okay, so I don't have a calculator on me, but that's going to come out at something like maybe 60 degrees or something around that region. Okay, so in fact, why don't you put in the comments the answer you get to this problem? Okay, post a comment with your answer to this problem. What is the inverse sine of 0.8? Okay, so let's do another example with sine. Say we know that sine of x equals 0.5, okay, and h equals 10. What, therefore, is O equal to? Well, we use SOHCAHTOA again, so sine of x equals opposite over hypotenuse, okay? But we don't know what the opposite is. But we do know what sine of x is. Sine of x is equal to 0.5. So 0.5 equals O over the hypotenuse, and the hypotenuse, we know here, is 10, okay? So it's O over 10. That is an O, not a 0. Okay? So, how do we work this out? We simply multiply both sides times by 10, so we get 5 equals O. So, if sine of x equals 0.5 and h equals 10, then O is equal to 5. Okay. So that's pretty simple. What about the CAH, the can of SOHCAHTOA? Well, that's almost exactly the same. Cos of x equals adjacent over hypotenuse. Okay, so this is if you know the adjacent, or the hypotenuse, or the angle in between. Okay, or you want to know them, and you don't need to worry about O. Okay, so you can just ignore that. You only need to know those three things there. In the same way that here you didn't need to know about the adjacent. Okay, but it works in exactly the same way. So say we have cos